then a bit from the course Geographic Thoughts that you are currently reading. So this course will just be rounding around, or will be going around these areas. Now, before we start, I just want to find out when we say geography, what comes to mind? When I mention the term geography, what comes to mind? When I mention the term geography, what comes to mind? Yeah, anyone, please. Yeah, okay, Idrisu.
Yes, geography means this. Hello.
Yeah, I'm listening.
Yeah, geography means the study of the earth or description of the earth.
Okay. So when we talk about geography, we try to look at the study of the earth. Is that okay? Now, Eratosthenes defined geography as the description of the earth and at large everything concerning what? Concerning the universe. They weren't only interested in just what is happening on the earth's surface, but rather they sought to understand how the universe operates and the likes. Now, when we pick or when we come into the field of earth science, one will ask, what is earth science? From your own understanding, how would you want to define earth science?
It's a scientific study of the earth.
So you refer to earth science as the scientific study of the earth.
Yes, please.
Now, when we look at the definition of earth science, again, it looks at using scientific approaches or scientific methods to understand how the earth operates. Now, it's important to note that the earth as we see it comes in systems. By systems, each of them operating in a specific way, but all in all, for it to help sustain human life. Now, when we look at the definition again here, it reads that it is a study of the earth and space, or it is a multidisciplinary science, and its purpose is to study the earth and the universe around it. And this universe around it, or the systems that we sought to look at, we are looking at what? The geosphere, the hydrosphere, the atmosphere, and the biosphere. Please take note of these words: the geosphere, the hydrosphere, the atmosphere, and the biosphere. In level 100, in the physical geography, these were some of the things or some of the concepts that you learned. Now, all these are systems that support lives, or they tend to operate individually or differently. But then its main goal is for us to understand how the universe operates. Now, for us man or for us humans, for us to understand how the earth operates, just a moment, let me project this. So as humans, we should understand that when we look at the earth, we don't just go up or we don't just get up and start to put things together, but rather there is an approach to which we operate. And that approach is what we call what? The scientific method or the scientific process. Is that okay? Now, with the scientific method, the understanding is things do not happen in isolation. Things do not happen in isolation. For one to get up and say that the earth is not round, the earth is not round as a ball, or the earth is not flat as a ball, it means that there has been a scientific process to which the person has followed. And how does this process work? First is to make observations. Before someone begins to question you or ask you about things, there is the need for the person might have made certain observations. Now, after making the observations, you tend to what? Ask questions. You sit and you analyze things for yourself. You begin to ask yourself questions. Why is this way? Why is the earth looking like this? Why do we have all these things on the surface of the earth? Now we move on to formulate hypothesis. By formulating hypothesis, what we do is we try to find questions, or we come up with questions that, okay, um, the surface of the earth is rough because someone has decided to. We've done all that topics already. Hello.
Hello, sir.
Yes, this is our first meeting, right?
We have
Yes,
met some.
please.
Sorry.
No, this is our first meeting. This is a intro, not this is intro. This is our first meeting. Now let's move on.
Belinda, you
Yes,
just
sir.
a moment, first. Yeah, Belinda,
Yes, sir.
have you ever met? Have you ever had a
We
class?
have met once. Yes.
Sorry,
Yes, we have met once.
we've met once.
Yes, sir.
Ah, I think that day your colleague they weren't around, but no problem, no problem. Let me just run them through so that we move.
Okay.
All right, great. Okay, so when you look at the scientific process, what we mean is you need to make observations, you need to ask questions, you need to formulate your hypothesis. Now, as you formulated a hypothesis, there's a need for you to test the hypothesis to make sure that it meets the standard. Now, once you test it and you begin to draw your conclusions or you see the results of it, then you go back. Maybe you are not satisfied with the conclusion, then you have to go back and ask more questions, formulate more hypotheses, test them, then you draw conclusions again until the conclusions have reached are satisfactory. You can't communicate the results. Please, are you okay? So when it comes to the scientific process, there is the making of observation. First step, you ask question, you formulate your hypothesis, you test the hypothesis, you draw conclusions. If the conclusions are inconclusive, then you ask questions again and you repeat it until the conclusions are satisfactory. You cannot communicate what the results. Is that okay? Now, to the definition of earth science, it says again, it is the study of the earth and space. And at large, it involves the study of what we call the geosphere, hydrosphere, atmosphere, and what? The biosphere. Now, earth science, like other sciences, assume that natural events or phenomena can be explained through thorough or careful observation and experimentation, meaning that they don't just everything that is happening on the surface of the earth or on the planet Earth can be explained. Is that okay? Now we moved on to the importance of earth science, where we try to understand how earth science influences human understanding. Now, let's look at it from Apostle, please can you mute the microphone? It's giving a feedback. All right. Now, let's look at it from a general perspective. When when you know about the earth or when you study about the earth, what are some of the advantages that it brings to you as an individual? Belinda,
Yes, sir.
I hope you heard the question.
Please come again.
So I'm saying that as an individual, if you know about what is the importance of knowing about the earth or learning about the earth?
So, say, I think it informs us about the things that, let's say, if you want to grow crops where you know you get the loamy soil or where water is, a place where you get water for anything that you want to use it for.
Okay. Um, Abdullah, Hafsa Abdullah, what do you also think? I'm marking my register. Hafiza Muhammad. Hafiza Muhammad, what do you also think? As an individual, if you are able to study about the earth, what is the advantage that you have? Apostle, please go ahead.
It informs you about the topography of the land.
So knowing about the earth helps you make informed decisions, such as you get to see how or where things are located in space, as Belinda mentioned. And as Reverend mentioned, you also get to understand or know the topography of the land. Is that okay? Now, when you get into your models, it helps us to understand, or it mentions that we're able to, one, have knowledge about where to extract fossil fuel, that is the crude oil, in terms of our mineral resource mining, and know where we can get water, and also about agriculture. Now, knowing about the earth as earth scientists or earth science students, we tend to have a better understanding of how the earth operates, how the earth is like, where we can find things of interest, where natural phenomena are occurring, and how it influences or affects our daily lives. Is that okay?
Yes, please.
Great. So, okay, good. Okay, let me open to this. Now, let's look at the branches of earth science. Let's look at the branches of earth science. Now, earth science is divided into major study areas. As I mentioned earlier, issues on the geosphere, the biosphere, the hydrosphere, and the atmosphere. We look at all these things. Now let's break it down here. The atmosphere, for the atmosphere, we'll be looking at issues such as what? Astronomy and meteorology. So astronomy, meteorology falls under what? Under atmosphere. We look at geology in terms of the geosphere. Oceanography in terms of what? The hydrosphere. Then environmental science in terms of what? The biosphere. Again, when we looked at the definition of earth science, we came to understand that issues about the geosphere, atmosphere, biosphere, and the geosphere, the atmosphere, the biosphere, and the issue about the hydrosphere are of interest to us. When we look at the major areas of interest or the major areas in earth science, we have astronomy, meteorology, geology, oceanography, and environmental science. Astronomy and meteorology happens to be under the atmosphere. Geology happens to be under the geosphere, where we try to understand the makeup of the earth. Oceanography looks at the ocean and marine life, where environmental science looks at the interaction between human beings and the environment at large. Please, I hope it's clear.
Yes, please.
Okay.
Yes, please.
All right. So that's what we need to know for this side. Things. Okay. Now, enough of this. Let me project the slide now. I just wanted to show you something over there. Project window and back to this. Okay. Please, I hope you can see the slides now.
Yes, please.
Okay. Now, there is what we call a system. There's what we call a system. Now, the system happens to be one of the fundamental concepts and themes in earth science. Now, when you look at a system, in the definition of earth science, I mentioned that we see it to be interrelated parts coming together to form a whole. Now, though they perform different activities, they all happen to what? To work towards making the earth what? Habitable. Now, a system is defined as a group of interacting or interrelated parts that form a unified whole. Again, a system is a group of interrelating or interacting parts that comes together to form a unified what? Whole. What this means is systems have um, parts or they have basic components that will come together. So, for example, when we pick a human being, there is the head. So there's this song that we sing, My Head, My Shoulder. Who knows how to sing that song? Can someone help us? We want
Yes,
to use
sir.
that to learn. Okay, so Belinda, let's give it a try.
Okay. My head, my shoulders, my knees, my toes. My head, my shoulders, my knees, my toes. My head, my shoulders, my knees, my toes. They all belong to Jesus.
Good.
I'm
Now,
done.
thank you very much. Now, there's your head, there's your shoulders, there's the knees and the toes. You'll notice that all these parts perform different functions, but then all of them come together or they make up what? The body. Please, are you getting the relationship here? So when you look at a system, there are different parts, but then all these parts have an influence on each other and they come together to form what? A whole. Now, systems ranges from being just simple to being very, very complex. Now, there are numerous types of systems. For example, we have the biological system, where we look at the heart and the circulatory system. We have the mechanical system. We have the human or mechanical system. We have the ecological system. We have the social system. So, for example, you having friends means that you have a social system. When you go for funerals, they tell that, oh, these are the friends of ABCD. The person, meaning the person has a social system. Now, what are the major characteristics of a system? One, they all have what? Basic components. For example, the Earth system, as I mentioned, has the geosphere, the biosphere, the hydrosphere, and the atmosphere. Though the geosphere has what it's doing, and the biosphere has what it's doing, the hydrosphere has what it's doing, and the atmosphere has what it's doing, they all tend to come together to work to perform a simple activity or a simple task. Is that okay? Now they have interactions and structure. Now they tend to um, communicate. So the circulatory system, the work of the circulatory system is to pump blood to the other parts of the body. Now, at any point in time, if the circulatory system ceases to operate, the body will go off or the body dies. The same way with the earth. Now, if the atmosphere is polluted, what happens to plants and animals? They begin to die. If the atmosphere is polluted, do we have rain coming in? If human beings tend to destroy the forest, will there be rain? No. What happens to the atmosphere? There will be too much carbon dioxide in the atmosphere, which will in turn what affect human living. Again, one characteristic of every system is that there is a goal. There is a goal. Systems will have results at the last part. Whatever happens with them, there's always what a goal. Then there's a behavior. Now with the behavior, example, how does the earth subsystem like wetland respond to disturbance from humans? Liken wetlands to be flood prone areas or what we call waterlogged areas. Let me ask, if you stay in a community or a place where it is waterlogged, when it rains, what happens over there?
It becomes
Step
swampy.
laughing.
The place becomes
Sorry?
very flooded. The place
Good,
becomes very flooded.
good. So you realize that the place will become what? Flooded.
Yeah.
Simply because human beings decided to build over there, meaning they have disturbed the natural habitat of the place or the natural makeup of the place. So what happens? It always responds to it. Then with every system, it has a life cycle. There's always a beginning and an end. Are you good?
Yes, please.
Good. Now, generally, we have there are so many types of systems, but I always say that the major ones that we need to know are open system, closed system, then isolated systems. Now, when we talk about open systems, let me see if they made this okay. Now, when we look at open systems, these are systems that do not that allows um, the exchange of both energy and matter. When we look at closed system, these are systems that allows for exchange of energy, but does not allow the exchange of matter, meaning it does not relate or it does not interact with its environment. Then with the isolated system, these are systems that do not allow the exchange of both energy and matter. They tend to operate on their own. They don't need anyone's contribution to come in. Then in terms of for geographers, we are also fascinated about what we call space, time, and scale. Now, when we look at space, we try to look at it as a location where something is happening. A location. Now, we can look at it as a concrete space or an abstract space. Now, when we talk about concrete space, these tend to represent the real world or the environment, what is actually there. Whereas the abstract space are those modeled reality that we put on paper. For example, maps. We have created an abstract of the real world or the concrete world onto a surface for us to use. Then when we talk about time, or temporal issues. Whenever something happens, there is what? There is a time to which it's occurring. It rained yesterday. Where did it rain? What time did it rain? Reason being that the time it rained in place A differs from where it rained in place B. So we look at what? The time part. Then we look at the next one being what? The scale. Now the scale primarily looks at the extent, how big or the size of it. So yesterday it rained heavily in some parts of um, Kumasi late in the night. With this statement, you notice that there is a space factor or a location factor. There is a time factor, and then there's a scale factor also embedded in it. No, we don't need this. Good. Now, when we look at the surface of the earth, there are two forces that have influenced the shape or the surface of it. They are constructive forces and destructive forces. Constructive forces and destructive forces. Now, constructive forces are those that shape, or they are those that tend to build up features and land masses. So when you say someone is constructing a house, you know how construction is. They place one on the other until it becomes big or it becomes tall. But then when you look at the second part, we'll be looking at it in terms of what? The destructive forces. By destructive forces, we look at the forces that bring down the features that have been that were initially made by the constructive forces. So, for example, you are putting up a building, you manage to bring it up, you have constructed it very tall, then all of a sudden a wind or something just pushes the entire thing to the ground. Now, the constructive force would have been all those forces that brought up or that made the building stand. Then the destructive forces will look at all those that brought what? The feature down to the ground level. Please, I hope it's clear.
Yes, please. Sir, please, your mic is on mute. Bella, Bella.
Anita. Annie.
I think the
I think it's
Bella. Hello, sir.
your
Sir,
son.
please, your mic is on mute.
Maybe it's the network.
Okay. Let's wait. Hello, sir. Please, your mic is on mute. Please stay connected. It has to do with his network. He will come back.
Oh, this network.
That is so not online.
I just spoke to him. It has to do with his network. So it's reconnecting to another. So hold on.
Apostle, Apostle,
Yes, please. Hello.
I was trying to, please, have you called Alexa?
Yes,
On,
I
Yeah,
said
hello.
yeah.
oh, okay. Sorry.
Yeah, my network is not fully back, but I think we can manage this for now. Only that I won't be able to share my screen with my mobile device, so let's just maintain it so it comes. Okay. All right. Good. Okay, so I'm back. Because I hope you can hear me now.
Yes, please.
Okay. Good. So we are talking about the constructive and the destructive forces. Now it's like when we look at the constructive forces, these are all forces that are responsible for creating um, land features. Is that okay? So they create them, they tend to make them. So we look at mountains, and examples of these constructive forces are volcanic eruptions, deformation, then deposition. Now, when we look at the destructive forces, we look at it as all the forces that are responsible for bringing down the features of interest. So we look at example like weathering, we look at um, erosion and the likes. Oh goodness. Now let's look at climate and weather. What is climate and what is weather? Now, when you talk about, let's speak from weather. When you look at weather, we try to look at the atmospheric condition of a place at a particular point in time, usually over a short period. So we try to look at the atmospheric condition of a place, usually, or the duration is mostly what? A short period in time. It could be just hours, it could be just minutes, it could be just days, it could be days. But then you also have climate, where climate you'll be looking at the where climate you'll be looking at climate you'll be looking at what? The weather condition. So an aggregation of the weather condition over a long period of time, usually 30 years. Is that okay? Usually 30 years. So you take note of that. So weather will look at the day-to-day changes in the atmosphere, whereas climate will look at the aggregation of these changes in the weather pattern over a long period of time, usually 30 years. Now, El Nino, El Nina, not really important. So, okay. Now let's look at these two words. We'll be coming across it day in, day out. Catastrophism and uniformitarianism. Catastrophism and uniformitarianism. Now when we look at catastrophism, it's a theory that believes that the earth as we see it has been largely influenced by sudden or violent events. So for example, immediately slap someone very hard, the person has a swollen face. That is what? Catastrophism. They believe that something happened, something violent happened. For example, the tale told about Lake Bosomtwe. It is said that a meteorite or a comet fell over in the area, and that's what influenced the creation of what? Of the crater, where today we have what? Lake Bosomtwe. In the same way, when we look at the uniformitarianism, it says that everything that is happening was done uniformly. Everything that is happening on the earth was done what? Uniformly. So that if we want to slap someone, we want someone to get a swollen face, oh, come here, then we just pat the person. Another day we pat the person. So gradually, we'll just be doing that until the person gets what? A swollen face. Unlike uniformity, catastrophism, which suggests that at once the world came into being. Uniformitarianism is saying that everything that happened was done what? Uniformly. It took time. It went through processes. Is that okay? It went through processes. Hudson, no. Darwin evolution, no. Big Bang theory, no. Okay. So the Earth as a system, great. Now the next thing I want us to look at is the Earth as a system. The Earth as a system. The definition of Earth science, we came across the geosphere, the atmosphere, the biosphere, and what? The hydrosphere. Now we'll be looking at one aspect of it, which is the geosphere. Going back to level 100, liking the geosphere or the geosphere is the same as the structure of the earth. The geosphere is the same as the structure of the earth. So let's have a short recap. How does the what is the structure of the earth? Can anyone help us? Structure of the earth. The structure of the earth. Yeah, hello. Yeah, anyone. When we say the structure of the earth, who can help us or who can give us a short description of the structure of the earth?
So the structure of the earth has to do with the makeup of the earth, as in layers.
Okay, please go on. Tell us more about it.
Yeah, as in layers from the earth crust, the mantle, and the core forms the structure.
Okay, that is good. Now, the layer that separates how many layers yes, how many layers does the core can we grow? How many layers can we group the core?
Sir,
Yes, madam.
yeah, I just want to try.
Oh, no problem. We are all trying. Me, I'm also trying to
And
teach
so
you.
I think we have the inner core and the outer core.
Correct for 3 points. So we have the inner core,
Yay!
we have the inner core and the outer core. Okay. What of the crust? What of the crust? Yes.
And the
Please,
one, please.
no, it's two.
It's two. Okay. I know the
Yeah.
rest.
So when you look at the core, there are two. We have the inner core and the outer core. When we look at the mantle, we have the upper mantle and the inner mantle. Then when we look at the crust, we have the continental crust and we have what? The oceanic crust. Is that okay? So we take note of that. Now it is the geosphere is responsible, or yes, it is responsible for the various landforms. That is the rocks, the minerals, the landforms on the surface, all those things. We get to see them what on the geosphere. Is that okay? So when we pick the geosphere, we try to look at everything happening on the Earth's surface and within the Earth's surface. Take note, the geosphere looks at what? The structure of the Earth, just like we did in level 100, physical geography. Now, of what importance or how important is the geosphere to human lives? Okay, please go on.
That is the human habitat.
Okay, so that is
Yes.
one. Any other?
Uh, for farming, even
For
voyage.
good. So what you'll notice that when we look at the importance of the geosphere to man, one, it serves as what? The habitat of human. It is on the land or it's on the geosphere that we get soil for cultivation. It's on the geosphere that we're able to what? Do a lot of things for survival. Is that okay? Okay, so now the next thing we'll look at is the structure of the atmosphere. Let's try again. What are the layers, or what are the layers in the atmosphere? What are the layers in the atmosphere?
So let me try. It's been a long time. I learned that the stratosphere
Good.
and the troposphere is long ago. So let me land here.
Are doing well.
The atmosphere, the stratosphere, the troposphere, and that's what other. There are three or so. Yeah.
Okay. So let's see if someone else will want to help you out. Anyone to help, Reverend? Okay. Now when we look at the atmosphere, we look at it in terms of what? The gases surrounding or the layers surrounding the earth. Okay. Now they are grouped into the troposphere, that is the first layer from the surface of the earth. We have the stratosphere, which is the second layer. We have the mesosphere, which is the third layer. We have the exosphere, then you have the thermosphere. So troposphere, we have the troposphere, we have the stratosphere, we have the mesosphere, then we have what? The thermosphere, the exosphere, then thermosphere also coming into play. So let's take note of that. Now, the earth as we see it, the atmosphere as we see it, is made up of just 21% of oxygen. The largest percentage, which is 78% of it, is comprises or consists of nitrogen. Meaning that the more we try to deplete the atmosphere, it is our life that we are putting at risk. Reason be that we just have 21% of what? Oxygen for human survival. Now, in the troposphere, the higher you go, so the troposphere is the first layer of the atmosphere from the Earth's surface. So in the troposphere, the higher you go, the cooler it becomes. The higher you go, the cooler it becomes. In the stratosphere, the higher you go, the hotter it becomes. This is as a result of what? The ozone layer. Now, the ozone layer exists within the stratosphere, and for that reason, as you move higher and higher and higher, it tends to become what? Hotter. The ozone is responsible for the absorption of the ultraviolet rays, which should it reach the surface of the earth, will be harmful for what? For human survival. Now, the mesosphere is the third layer from the Earth's surface. In this layer, the higher you go, the cooler it becomes. So it's more like a reverse movement. Stratosphere, the higher you go, the troposphere, the higher you go, the cooler it becomes. Stratosphere, the higher you go, the hotter it becomes. Mesosphere, the higher you go, the cooler it becomes. Then in the thermosphere, the higher you go, the hotter it becomes. Now, in all these layers, they have a point of change. Is that okay? Now, by a point of change, we try to look at a boundary that separates the layers. For example, between the troposphere and the stratosphere, there's a boundary, and that boundary is called the tropopause. Between the troposphere and the stratosphere, there's a boundary called the tropopause. Now, between the stratosphere and the mesosphere, there's a boundary called the stratopause. Between the stratosphere and the mesosphere, there's a boundary called what? The stratopause. So therefore, between the mesosphere and the thermosphere, what will be the name of the boundary there? Let me mention names. Seems the class has been left for just 2 people. Okay. Ivan Sowusu. Hello, Evans.
Sir,
Good.
hello, sir.
Did you get? Yeah. Did you get the question?
Please, the network is a little bit bad. Hello,
Oh, okay. Yes, ma. Yes,
hello.
boss. Yeah. Hello. Can you hear me?
Yes, please, I can hear you right now.
So I'm saying that between the troposphere and the stratosphere, there is a layer that separates the two, and that layer is called the tropopause. Between the stratosphere and the mesosphere, there is a layer that separates the two, and it's called the stratopause. So, what will be the name for the layer that separates the mesosphere and the thermosphere?
It's mesopause.
Good. So that layer is called the mesopause, not menopause. So please note, it's not menopause. It's what? Mesopause.
Okay.
Mhm. All right. Now let's proceed. Oh. All right. So when you look at this image here, now if you look at this image here, you see that we have the troposphere, which is the first layer. We have the stratosphere, we have the mesosphere, we have the thermosphere, then we have the what? Exosphere. Now, each layer as we see it has a role it plays in human living. For example, the troposphere. The troposphere is the layer in which man is able to survive. This is where elements of weather and climate happen. Travel. Human beings or aircrafts are able to travel within this layer. Or the normal aeroplane that we see, they tend to travel within what? The troposphere. Now, the stratosphere, as I mentioned, has the ozone in it, and is responsible for the absorption of what? The UV rays. So as we see it over here, between the troposphere and the stratosphere, there is a borderline called the tropopause. Between the stratosphere and the mesosphere, another borderline called what? The stratopause. Then between the mesosphere and the thermosphere is another borderline called the mesopause. Is that okay? Are we clear?
Yes, sir.
Great. So now we've looked at the geosphere, we looked at the atmosphere. Please note, these are no different from what you have been taught or what you were taught in first year under physical geography, the structure of the earth and the structure of the atmosphere, I would encourage you to kindly go and have a second look at it. You can go and read a little about it so that it will broaden your scope in understanding this. Is it okay? Is there any question up to this point?
Hello, sir.
Yes, boss. I'm all ears.
Hello. Hello.
Yeah, hello. I can hear
Please,
you.
I couldn't get a question because my network was very bad.
Oh, don't worry. I was saying that you are out. We'll
But
put.
I couldn't get your question well.
Oh, okay. Reverend, please can you type the question in the chat box for him so that at his leisure he can look at it. Who knows? It can be an exams question.
I'm taking the notes, so I'll put them there.
Okay, sure. Thank you very much.
I'm also welcome.
Okay. So the next sphere that we'll be looking at is what we call the hydrosphere. Now, the hydrosphere, it is the same as the hydrological cycle. I don't know if how many of you remember the hydrological cycle. Can anyone tell us about the hydrological cycle? Belinda? Belinda, can
Say
you
please.
tell, mhm. Can you
No,
tell us about
please.
the hydrological cycle?
No, please.
Hey, okay, anyone? For 3 marks, can anyone tell us about the hydrological cycle? Jacob?
Say,
Hey,
it's all
Rita?
about the water cycle.
Hey, hey,
You want famous.
Yeah.
So we know hydro is water.
hey, Rita?
Yeah.
Uh, okay, why?
Hey, when I said for 3 marks, see how everyone's microphone just turned on. Interesting. Okay, Rita, please tell us more about the hydrological cycle. What do you know about it?
It's all about like some when the heat absorbs energy,
So,
uh,
Rita,
comes
see, Rita,
to
hello,
uh,
Rita. Okay, so take your time.
yes.
Assume that we don't know anything about the hydrological cycle and make us understand it.
Okay. When heat absorbs energy, when the heat absorbs energy, it always goes to the atmosphere and now condense it and it will fall as rain. You assist.
I should assist her. Let's see. Evans, Evans, let's see if you can assist. Where's Evans? Evans has run away. Okay.
You want her to run.
All right. So Apostle, before I come to Anita, Anita has not said anything. Anita can come.
Say,
Yes, madam. Please tell us something small about the hydrological cycle.
I know it's about how rain falls. So from the evaporation, go to condensation and something like that.
Okay.
Hello.
Yeah,
Say,
hello. Yes.
yes. Say that is all I can say about it.
Okay.
Mm.
Jacob Green. Jacob, let's
Okay,
hear
sir.
you.
Yes, sir. It's about water cycle. So we
Mm.
start from the evaporation. So water from
Mm.
the earth evaporates into the sky. That is, it tends to gas. And then when it gets to the atmosphere, it condenses. It condenses and turns to water vapor. And then when the earth the cloud couldn't the sky couldn't hold it anymore, then it precipitates. That is, it falls back as rain or snow. Yes, sir. That's all I can say about it, sir.
Jacob, which center are you from?
Um, I'm at St. John's.
Takrade.
Yes, please.
Did I teach you for physical geography? Wait, come.
No,
Are you
sir.
a top up student?
Yes, please. I'm a top-up student, sir.
Okay, means last semester you were in there.
Yes, sir. This is my first.
Yeah,
So
most of us are top.
oh, okay. So I'm asking this because of a word you use. The word is precipitation. Now,
Yes, sir.
more often than not, we always say that it falls back as rain.
At rain.
But
Yes, sir.
rain, yes, but rain is just a portion of it. What if the area that you are talking about is snows?
Yes,
Would you say
yes.
that it falls back as rain? You say that it falls back as snow.
Okay, sir.
So the right word is what you mentioned. It falls back as what? As precipitation. So you have done well. Eh? Your 2 marks is with me.
Okay, sir. Thank you, sir.
Rita, I know you asked me you to do get marks. I'll give you one, okay?
Hey, sir, Abba.
All right.
And the man in Nabi, why? Yeah, for sure.
Oh yeah, yeah, Madi. Me more be Madi. All right. So when it comes to the hydrological cycle or let's pick the hydrosphere. Now the hydrosphere encompasses or it combines the mass of water found on the surface of the earth, above the surface of the earth, and under the earth. Is that okay? Now all forms of water or water in all its forms, whether in a water vapor, whether in ice or whether liquid, the hydrosphere considers it. Is that okay? So water in either ice or liquid, solid, or in its gaseous state, the hydrosphere is interested in it. Now, oh, please hold on just a minute. All right, sorry, I'm back. So when you look at the hydrosphere, it combines what? Um, Mass of water found on the surface of the earth, above or under it, in all forms. So whether liquid, solid, or what, or gas. Now, the Earth's hydrosphere has been found or has been around for about over 4 billion years, or since the Earth was brought into being, and it keeps changing. It keeps changing as a result of what we call the sea floor spreading or continental drift. I believe these two words you have come across them before.
Yes, sir.
Okay, that's good. So it makes the work easy. Belinda, if you have come across it, then what is sea floor spreading or what is continental drift? Which of them can you answer?
I'm not the one who respond.
Who responded? Belinda, dear
I'm
Kamelumo. Was it Rita? Yes, I think it was Rita.
Sir,
Yes, Rita, what can you tell us about? You said yes, you have heard it before. What did you hear about it?
So I don't know much about it too, but I've heard of that continental drift.
Okay. Apostle, please help us out.
So, is it the movement of the tectonic plates?
Great. So when we look at continental drift, the earth or the continents are on plates. So these plates keep moving. Now, as a result of their moving, it changes what the flow of water or how the ocean flows. It changes it or it influences it what greatly. Oh, sorry. So as I mentioned, we look at water in all its form or all the three forms. Now, one will ask, how is the hydrosphere changing? Number one is human contribution to green gases or greenhouse gases. Now, first, we knew that. How many of you have noticed that the Hamatan season or period has changed? When last did it rain during the Hamatan season? Can anyone remember? Aside this year.
Only this year, say.
So you notice that this year everything has changed.
Yes,
The
please.
Hamatan then starts when it should have started.
Mm.
And even during when it started or as it has started, it is still raining. Now the
Yes.
question now the question is, when we get to the rainy season, what will happen? I'm sure we'll be experiencing thunderstorms because if
Mm.
Hamatan and it's raining like this,
Raining,
then
yes.
when it gets to the raining season, then we should experience more rain and more deadlier ones because everything has changed.
Life and
Now,
everything.
mhm, okay. Then again, there are some evidences of what that suggests that global warming is responsible for all these things. The burning of rubbish, those petty things. You go to the farm, you burn rubbish in your houses. You go to the farm, you set it on fire so that you burn the wheat in your houses instead of taking the rubbish to the bin. Oh, wait, the mention where actually no, so the car, but a man be this until the moment show higher, then all those things we introduce harmful gases into the atmosphere, which in general what affects um, how the layer that protects the ozone layer. So it depletes the ozone layer, which in time affects human living. So this is an image of the hydrological cycle. This is an image of the hydrological cycle. So evaporation, as mentioned, then we have evapotranspiration or transpiration from plants, both entering into the atmosphere. There's condensation. Once it condenses, it comes down as precipitation. Precipitation then reaches the surface of the earth. Some of them goes or it infiltrates into the soil. Others will have what we call the surface runoff. Then others to have what the ground flow, the groundwater flow. So water from the ocean gets into the atmosphere, water from the plants gets into the atmosphere. Then there's condensation, then it comes down as what? As rain. Please, I hope it's so it comes down as precipitation, sorry. So precipitation, evaporation, transpiration. These are all terminologies that you'll be coming across. Then possibly this might be the last one, the biosphere. Okay. Now the biosphere. The biosphere is the layer of the earth of the planet Earth where life exists. Basically, it looks at how humans interact with where life exists. So, on the surface of the earth, how do humans relate with the environment? In the atmosphere, how do birds relate or interact with the atmosphere? Um, Under the earth, how do animals also interact with the environment? In fact, how do galamsey operators also relate with the environment or the underground environment? Now, all these things are issues that we need to look at or we consider when we are looking at what the biosphere. Now, in the biosphere, it includes all forms of what microorganism, microorganisms, plants, and animals of the earth. Now, it is within the biosphere that living things form what ecological communities based on their surrounding areas. For example, it is within the biosphere that we have what domestic animals. It's within the biosphere that's where we have what wild animals. Now, all these things are as a result of what the existence of the biosphere. Very good. Now, the community or the ecological communities that are formed by these microorganisms are called the biomes. So you take note. So this word, oh, when I tried to highlight, I was trying to highlight. So take note of this. So the communities in which the microorganisms are created or the surrounding in which they are created are known as what? The biomes. Um, so we have the flora and fauna where we look at what? Plants and animals. So generally our biosphere is divided into by a number of biomes, mainly inhabited by what? Plants and animals. So plants is what we refer to as what? The flora, and animals is what we refer to as what? The fauna. So we take note of that also. I'm just trying to sample out and pick out the main ones that we need. Um, okay. So we are just around the edge so that we can call it a day. Um, just a minute. Okay. Now let's look at energy flow in the Earth system. Remember when we're looking at systems, we said we have generally three types of system. Can anyone help us recall the systems we mentioned? The three types of system that we mentioned.
Yeah.
Yes, can anyone help us with the types of system we mentioned?
So was it the skeletal system?
No, the
Other one.
systems, the systems in geography.
Oh, okay.
So please, is that the open system and the closed system?
Good. So we have the open system and the closed system. Very well. And I also mentioned that with the open and the closed system, what differentiates it? What are the differences in the two?
So, sir, for
I
the
think the
open system. Oh, okay.
Yes, we will go first. Someone should talk about the
Sir,
open system.
okay. I think for the open system, you said they allow external interaction in the environment
Okay,
because it's
good,
open to everything. Yes. That's what I'm saying.
good. Then what of the closed system?
Me or different person? I should I have.
Oh, you can answer it.
Okay. For the closed system too, they do not allow any external interaction from the environment.
Okay. So let's take it this way. When you talk about the open system, they allow interaction with the environment. That is exchange of what? Energy and matter. Then when you look at the closed system, it does not allow the exchange of matter, meaning it does not interact with what? The external system. So let's use those two keywords. The exchange of energy and matter, that
Matter,
is
okay.
for the open system. Then for closed system, there's the exchange of energy, but then there's no exchange of matter. But just say I said, yeah,
That's right.
great. Now, within the Earth system, there are three forms or three transfer of energy that we need to know. There is radiation, there is convection, and there is conduction. Let's go back to school. What is radiation? Yes, what is radiation? What is convection? What is conduction? Okay, yeah, please, I'm listening. Hello, Reverend. Please, you can go ahead. Please proceed.
Hello,
Yeah, hello, we can hear
am I
you.
clear?
Yes, we can now hear you.
Okay, okay, sir. Radiation is the energy that comes through a source and travels through spaces or medium like air and water.
So, please, you said like what?
Radiation is the energy that comes from a source and travels through space or mediums like air or water.
Okay, that's good. That's good.
And it's usually electromagnetic.
Reverend, wait, that's why all kind of the time.
So I'm referring to my SHSBs.
Okay, all right. So when we look at radiation, we look at energy that is transmitted through space. There is Reverend, please kindly mute your microphone for me. So in when we look at radiation, we try to look at it such that the exchange of energy or the energy transmission does not go through any solid medium. Is that okay? Then what of convection? What of convection? Hello? What of convection? No one. Going one, 2 months going. Okay, so 2 months gone. So when you look at convection, this is a type of what? Physical movement of what? Of fluid. So there is when you come to convection, there is a medium in which they happen. Um, for example, when you want to grill something in an oven, it uses either the radiation or the convection method. Then when you look at conduction, we try to look at what? The transfer of heat in the transfer of energy in form of heat through a medium. So when you are cooking and you leave your metallic ladle or yes, your metallic ladle in it, then you know that okay, this is what will happen. There will be transfer of heat from the saucepan to the individual, or two, the what do you call it? The ladle that has been left in it. Is that okay? Okay, that's just about it. Then we also have the biochemical cycle. I would encourage you to read on that. Please, are there any questions up to this point? Hello, are
So
there any
it's
questions?
not, so it's not a question, but most of these things are not in our handouts.
They are not in your handout.
Most of them.
Most of
I don't
them.
know if I don't know if it is limited to me.
Wow. So let's do this. Share the documents you have with me.
Okay, sir.
Okay, so share with me and let me look at it. If it's the same as I have.
I'm sharing the right now.
Okay.
And I want my colleagues to reconcile with me. Please, you have this the same as I'm saying. Hello.
Hey, wait, that's one person more new more.
Yeah.
Belinda,
It's
Hafsa, is it Hafisa or Hafsa?
Sir, please, it's Hafsa.
Hafsa.
Yes, please.
Okay. Which center are you from? Are you also from Takwari?
No, I'm in Accra.
You are in Accra. Which center?
Saint Lucian.
Kanda.
Yes, please.
Kanda Lutheran.
Yes, please.
Hey, your people, they come for class. Oh,
Sir,
yes, madam.
they were calling me. Sorry.
No, Hafsa, sorry. Hafsa, let's talk after class,
Yes.
okay?
Okay, sir. Okay.
So you can text me
So I
after.
mean, are you cool?
Okay.
My
Belinda,
center is Oyoko.
Belinda, your center is Oyoko.
Oyoko, yes. So for
Then
you.
Hafsa, your center is Lutheran Kanda.
Yes, please.
Wow. Because you Kanda, I know they have face to face. Level 200. Where do you stay?
I start to pass it.
You start Popiase. Bloody.
Yes,
No
please.
be today. Oh. Okay, you don't worry. During the quiz, you'll see me at that place. You'll be writing your quiz at Kanda, right?
Yes, please.
We'll meet. I'll certainly look for you. Or you the day of your quiz, when you come there, just ask them of Oheneba or Sir James, any of them.
Okay, sir.
All right. Because I know
Thank
your
you.
people, they meet face to face, so I'm a bit surprised. Okay, Reverend, please, I'll be looking forward to the document, okay?
okay, sir.
All right. So I believe if there are no questions, can we call it a day?
Yes, please.
Okay,
So,
sir.
sir, when are we meeting?
Sir, please, I want to ask this question.
Okay.
Sir, please, we don't have it. When are we going to get our handout?
Have they given you the soft copy of it?
No, please.
Ah, you don't have the soft
We
copy of
have,
the application.
yeah,
They've
we
sent
have,
them on the platform. We
we
have.
have. I think I even
Sir,
shared.
Yeah, they sent it in the group. The model, yes, model.
at the WhatsApp platform.
Reverend, I think you should kindly share on the platform again, okay? But then
Right.
you can send to me. Then let me look at it if it's the same as what I have.
Yes, please.
Sir,
Right. Yes, madam.
Can we get quizzes past questions?
The ones I have are not for you. They are not for 200. But then I'll go through and see. Okay. I'll check
Okay.
and see if there are some in it.
Okay, thank you.
You're welcome. All right. So thank you very much for your time, Reverend. I think we can have a discussion on the next meeting. I think we have to have one more meeting before you go in for your quiz. So we can have a discussion backstage, and then we have it. All right.
Okay, sir. I've even
All right.
handout on the platform, the PDF, on our WhatsApp
Sure.
platform.
Okay.
Right, that we have done. Okay.
Yeah, it's the same
So,
thing. That's the same document.
yeah, but when you go through, we have some, the picture, the imaging, and a lot of things are not part as we have it.
Oh, okay. So the when it comes to slides, okay, they are lecture. They are different among lectures. So maybe an image that I believe can help you understand things better, I'll use it in my slide. So if you notice, my slides is more of a summary of. It can be a summary of about 3 pages or 4 pages. Is that okay?
So at a point I was like, which page are we? Because it
Yes.
wasn't in line with what we have here.
So you have the same thing in your books or in the model. Because I use the model
Yeah.
in
But
putting the slides together. Hello, Reverend. Please, I'm listening.
I will go through it and see.
Sure,
But I've shared it with
sure. That's
those
fine.
on the platform.
Okay. All right. So thank you so much, everyone. Do have a good evening and enjoy the rest of your week. Those who will be eating Valentine, happy Valentine in advance. Those of us who will be
Thank
eating kinky, we also do also enjoy our kinky.
Okay, sir.
you.
All right. Bye.
Okay. Bye.
Bye.
Bye bye.
Bye.